Hey math fans, we're on section 5.1.2. Let's get started. The word transform means to change, and we're going to be looking at a lot of different transformations in this class. A transformation could be the position of the original object, the shape, the size, but here's some vocabulary that we're really going to need to get down. The after picture is always called the image. The before picture is always called the pre-image. If a point has changed, let's say from point A to some other point, it'll be denoted as A prime. So A would be the pre-image, A prime would be the image. Now, if the object has the same size and shape as it did before, it's known as isometric or an isometry. And the image and the pre-image will be, the vocabulary term is congruent. Here's one of the more basic transformations. This one's called a translation. So here's the notation that you're going to see. You're going to see usually the capital letter T followed by X comma Y, and then it will tell you how much you are adding or subtracting from the X and Y value. Here's an example of a problem where they were taking a triangle ABC and using the shorthand version, where if you have a capital letter T and then you have two smaller numbers separated by a comma, that tells you how much you're going to be adding to the X value. Notice 5 is being added to the X value, and how much is being subtracted or added to the Y value. We're subtracting 3 from the Y value in this particular case. Another vocabulary term that comes up a lot, especially in transformations, is one-to-one. In other words, for every point, there's going to be another point that's going to match up. Now notice this example over here is not one-to-one because both B and C are transforming into one value. So it's got to be for every one input, there's going to be one output. So here's where it gets a little tricky. I can define S as a particular function, and then I can define T as a particular function, and then I can combine them. Now, combining them doesn't mean just adding them. It means actually one is going to go inside of the other. And so the rule of thumb is this. If I have a function on the outside and then a function on the inside function gets done first and then followed by the outside function. Here's an example of where you can see that, first of all, the T function is being done first, followed by the reflection function. So notice that the T, first of all, you have triangle ABC. That's on the inside. We always start on the very inside. And then we translate it first, and then we do the reflection. So it works from the inside out. Let's all say that together. We work from the inside out, and that's how you can keep track of which one you can do first. So when a pre-image and the image are congruent, we call that isometric. It's also known as a rigid transformation. The most famous rigid transformations are a translation, a reflection, and a rotation. Non-rigid transformations, or transformations that are not isometric, might be, stretched horizontally or perhaps even vertically. And it doesn't have to be to a certain scale. Whenever you multiply numbers, that's what's going to happen, is you're going to be stretching or compressing. So note that the before and after, these segments are not equal, therefore the transformation T is not isometric. Finally, we have a dilation, and a dilation happens when you have a multiplied factor for both the X and the Y, and it has what is called a scale factor. I abbreviate that SF. So this would have a scale factor of 2. In other words, the image is going to be twice as big as the pre-image. Let's take a look at some examples. So you have a point P, 5, 3, and we want to translate this. I can tell it's a translation because we're either adding or subtracting. In this case, we're adding 2 to both the X and the Y values. And so what this is going to do is just glide point P basically to the right 2 and up 2. And the new point will be 7, 5. Of course, maybe it's an entire triangle. So here's an example where you have A, B, and C in these given points. And then you have a transformation. Now, this is not going to be a translation because I am not adding or subtracting values here. In fact, I'm multiplying by -1 here. So it's going to be something other than a translation. But it still uses the letter T, which I guess they just mean for a transformation. So let's see what kind of transformation it is. Basically, the x values will stay the same, as you can see, because it just says x. And the y values, we're going to be taking the opposite of them or multiplying by -1. And then we will graph them. After we graph them, we can see that this specific transformation was indeed a reflection. And if you look closely, all you have to do is measure the distance between the before and after points, and you can get what the line of reflection is. In this case, it's going to be the x-axis, or y is equal to 0. It's going to be the line of reflection. Here's another transformation, but notice that they're using the shorthand version, which is going to mean that you're going to be adding 5 to the x value, subtracting 3 from the y value. And then we can get our P prime point, which is your image, and then we can graph them. I think this is a typo. This should be a Q. And finally, it says, given that t, -6, 2, in other words, you're going to be subtracting 6 from the x value, adding 2 to the y value, state the translation that would yield the identity. Now, an identity transformation means it will take the original object back to where it started from. So let's think about this here. If we are translating something 6 units to the left and up 2 units, wouldn't it make sense to move it back to where it started? We should be moving it to the right 6 units and then down 2 units. So again, we're just kind of undoing what we did. And there's your final answer for the identity transformation. And that's going to do it for this section. We'll see you in class.